Hello there, Mr. Sutton here, bringing you the BC Calculus 8-1 Extra Practice Number 2 solutions on parametric functions. For this problem, I'm given the derivative of x and y both with respect to t, and I want the second derivative of y over x. So for this one, we're going to have to first find dy over dx. And to do that, since we're dealing with a pair of parametric derivatives here, we're just going to have the equation dy over dt over dx over dt. So basically derivative of y over derivative of x. Now the good news is they've already given us both of those. So this is just going to be sine of t squared over 5. So that's dy over dx. Now to get the second derivative of y with respect to x with a t variable, we're going to have to take the derivative of what we just got here with respect to t and divide that by dx over dt. So this is the setup formula-wise. We have the derivative of this thing with respect to time divided by dx over dt again. So a derivative of this thing, that's going to be, let's see here, you can think of this as 1/5 sine of t squared, so the derivative is going to be 1/5 cosine of t squared times a tail, a chain rule here, of 2t. And now we're dividing that by the derivative of x with respect to time, which again, they gave us that, so that's just 5 again. And we're going to have to simplify this to get an answer choice. So this is going to be 2t cosine of t squared all over this 5. It can come down here and be a 25. And that's going to match answer choice C. For this one, we have a curve defined by parametric functions x of t and y of t. And they didn't tell us what those were exactly, but they did give us the derivatives of those parametric functions. We want to know for what positive value of t the second derivative of y with respect to x equals 1. Well, in order to figure this out, we first need to write a formula in terms of time for d squared y over dx squared, set it equal to 1, and then since this is a calculator problem, that's probably the point at which we're going to let the calculator do the rest of the work for us. So let me get that second derivative. First, I need the first derivative, dy over dx. To get that, I need to take the derivative of y over the derivative of x. So dy over dt over dx over dt. Now the good news is they already gave us these things. So this is going to be t to the 7th minus 2t to the 4th over 3t squared. And just one little thing I'm going to do, because I know I'm going to have to take the derivative of this whole thing in a minute. I'm going to actually divide both of these by 3t squared, just so it's a little bit easier on the next step. So I'm going to call this, let's see here, this will be 1/3 t to the 5th minus 2/3 t to the 2nd. All right, so for my next step, finding d squared y over dx squared, that's going to be the derivative of dy over dx with respect to time, divided by derivative of x. So that's going to be the derivative of this thing that we just came up with, divided by 3t squared again. So for the numerator here, I'm going to have, using my power rule, 5/3 t to the 4th minus, and then this is going to be 4/3 t. All of that over the derivative of x, which again they gave us that was 3t squared. And we needed to know at what t value this thing has a value of 1. So I'm going to set this equal to 1, and we're going to solve this on the calculator now. So here I am on my calculator in the y equals. In y1, I've put the left side of this equation right here, and I made a very generous use of alpha y equals to get my fancy fraction mode here to sort all that out. On y2, I put the right side of my equation, which is just the constant value 1. And for the window, not really sure what my window should be. I've got kind of some rough guidelines here. The answer is going to be somewhere between 1 and 2. But I don't know. Let me just do zoom 4 for window and see what we get. So there is the second derivative. And really, we're just focusing on this area. And we see that we are intersecting somewhere between 1 and 2. So let me just find this intersection point right here. That's going to be second trace option 5 for intersect. And where's my spider? Let's see here. Let's move that closer to that intersection. There we go. And then just press enter 1, 2, 3 times to get 1.525 if I round that off. There we go. So that's going to end up being answer choice D. On this problem, we have a curve in the xy plane defined by this x of t and y of t set of parametric equations. We're just trying to find the slope of the line tangent to that curve at the point where time equals 2. All right, so for this, we're going to need both x prime and y prime, and then we'll put it all together. For x prime, just using our power rule, we've got 12t squared. And for y prime, we're going to use a little bit of a chain rule here. This is going to be 3 times all of this stuff to the second power times the derivative of the inner function, which is going to be multiplied by, now we got a 6t coming out there. So to find the slope of the tangent line, we need dy over dx. So that's going to equal y prime over x prime, the way these parametric deals work. And I'm going to clean this up as I plug this in. So I can rewrite the y prime here as 18t times 3t squared minus 4 quantity squared. And then here's x prime. I'm going to reduce a little bit here. So this is going to be a 3 over a 2, and we have a t downstairs and no t up here. So we have a 3 parentheses 3t squared minus 4 squared all over 2t. And the reason I'm bothering to simplify this is I know I'm going to have to plug in 2 for t on this very next step here. So I'm just trying to make my life a little bit easier. So now let me go ahead and do that. So we have 3 times 3 times 2 squared minus 4 squared all over 2 times 2. I'll take this in a couple bites. So inside we've got, let's see here, this is going to be 3 times 4, so that's 12. Subtract 4 from that, we've got 8. And square all that, we've got 64. So 3 times 64 over 4. 64 divided by 4 is going to be 16. 3 times 16 is 48. So that helps us match the answer choice D. For this problem, we have a curve defined by x of t equals cosine of t and y of t equals sine of t. This is a parametric curve. We want to find the second derivative in terms of t. So to find that, we have to first find the first derivative, just dy over dx in terms of t. That's going to be a dy over dt over dx over dt. So then dy over dt, the derivative of this y function, that's going to be cosine of t. And dx over dt, derivative of cosine of t, that's going to be negative sine of t. And just to make my life a little bit easier, because I know I'm going to have to immediately take the derivative of dy over dx, I'm going to simplify this to negative cotan of t. So for my next step, to find the second derivative with respect to time, I'm going to have to take the derivative of dy over dx with respect to time and divide that by dx over dt. So this is my setup for this, d over dt of dy over dx. So basically derivative of this stuff, and then divide that by this negative sine of t that I divided by before. So derivative of negative cotan of t, that's going to be cosecant squared of t. And again, we're dividing that by negative sine of t, because that's what dx over dt is. And this doesn't match any of the answer choices, but not to fear. We can simplify this a little bit. Cosecant squared is really 1 over sine squared. So combined with this sign, that'll give us negative 1 over sine cubed of t. So that ends up being answer choice C. For this problem, we have the set of parametric equations x of t and y of t. We just want an expression for dy over dx in terms of t. So the derivative of y with respect to x for a parametric set of equations is just going to be basically y prime over x prime. So y prime is going to be negative 2e to the negative 2t. And for x prime, this is just going to be 2 times e to the 2t. So just a couple quick chain rules there. And we're going to have to simplify this to get one of these answer choices. So these 2's can cancel. We have a negative. We also have, let's see, this is going to be e to the negative 2t minus 2t using our exponent rules. So that's going to be e to the negative 4t. So when the dust settles, we have negative e to the negative 4t. And that is going to match answer choice A. For this one, we have a curve defined with x of t and y of t. we want the second derivative in terms of t. To figure that out, we're going to have to get dy over dx in terms of t, and that's going to equal, in general, dy over dt divided by dx over dt, basically derivative of y over derivative of x with respect to time. Derivative of y, taking a look here, that's going to be 4e to the 4t plus e to the t. And now derivative of x, that's going to be 2e to the 2t, and then this 3 goes away, it's just a constant. I'm going to simplify this a little bit just because I know I'm going to have to take the derivative of this whole thing, and I would like to avoid using the quotient rule. So we divide both of these by 2e to the 2t. So for this first term, this is going to be, let's see, 4 over 2 is 2. We have exponent rules going on. This is going to be e to the 4t minus 2t. So altogether 2e to the 2t. And then we have e to the t divided by 2e to the 2t. That's going to be 1/2 e to the negative t, because we're doing, again, t minus 2t there. So for my next step here, I've got to take the second derivative. So I have to take the derivative of dy over dx with respect to time. So d over dt of dy over dx. So basically take the derivative of this thing. But then we have to remember to divide that by dx over dt. That's how these work. So let's take this derivative first. This is going to be 4e to the 4t plus, well, actually minus 1/2 e to the negative t. So a lot of chain rule going on with these exponential functions. And down below we just have dx over dt again. So just 2e to the 2t. We already found that. And now we have to actually simplify this to get one of the answers, it looks like. So 4e to the 2t divided by 2e to the 2t. Well, these e to the 2t's cancel there. So that's just 2. And for this next one, let's see here. Negative 1/2 divided by 2, that's going to be negative 1/4. And we're going to have e to the negative t minus 2t. So e to the negative 3t to go along with our negative 1/4. And that is going to match answer choice A.